Okay, today's lesson is on AICE modulus questions, where we're going to try and solve equations of the form that you can see in the objective there. Let's take a more detailed look at exactly what we're going to cover in today's lesson. We're going to start by looking back at some absolute value graphs that we looked at in the previous lesson. We're going to do some review of transformations of graphs, because these questions tend not to be in isolation when you do them on the AICE test themselves. We're going to look at questions that you won't have seen in Algebra 2, where absolute value functions equal another absolute value function. And you can see from examples 1 through 5 that those are a little different than what you've seen previously. So that's what makes this really the AICE content for this. And then the assignment at the bottom you can see as well, where we'll be using the textbook to answer some more questions. So first of all, let's start off with the actual warm-up itself. You might want to pause the video at this point, and it's very possible there's a sheet as well from Canvas that you can look at to try these questions as well, and then we'll take a look at the answers. So this one was just translated to the right, so that's going to be a transformation inside the absolute value. This one was moved up 2 places, so that's after the absolute value at the end of the equation. This one also had a slope of 1/3. It went up 1 and across 3, and the graph moved down 3 places, which is why it ends in -3. Let me scroll up just a little bit more so we can see 4, 5, and 6 easier. This one just moved across 2 to the left, so +2 inside the absolute value. This one I can see is upside down, so I know this one's going to be a negative graph. And also it was 1 place to the left, so I needed +1 inside the absolute value. And a lot going on this last one. Certainly negative because it's upside down. The initial slope goes down 2 and across 1, making it -2. I also moved it 1 place to the right, the vertex, and I moved the vertex up 2 places as well. So I would need each of those components as well. Let me quickly just reset that page. The homework part we're not going to look at. There's actually a second question. I put warm-up 2 on my side notes here, but this is really just an AICE review. So figure 1 shows part of the graph curve with equation y equals f of x, where f is an increasing function of x. Now the increasing part doesn't tell you much about this, except you can see that the graph is just going up throughout the place. Now there was a couple of other things labeled, but you can see them in the picture. So it gave you the coordinates of p, and it gave you the coordinates of q. I'm going to leave that untyped because you can clearly see that within the picture anyway. You might want to pause the video. You might want to try part A and then see if you can remember how to do part B and C. And then we'll come back and then we'll look at the actual answers for this. Make sure you read carefully. Indicate clearly on the sketch any points where the curve crosses or meets the axes. So that refers to x-intercepts and also y-intercepts. All right, let's take a look at the answers then. This is the initial graph. We're told here we've got to do the absolute value part. So remember, absolute value takes anything that is negative and makes it positive. So this part of the graph here is just fine because this is all positive. This part of the graph, though, is negative, which is not allowed. So this is the one where we flip it over the x-axis, or we do a reflection in the x-axis. So this coordinate here, 0, -2, the -2 part, when you flip it, is going to move up to +2. So the graph should look like that. When we get to the next one, f to the -1 of x, that's your inverse function. This is chapter 11 from AICE 1. The property is that it's a reflection in the line y equals x. Now, a more basic definition of inverse that you might remember is that the x and the y values flip over. So 3, 0 would become 0, 3, which I could plot. 0, -2 would become -2, 0, and you can plot that one as well. And you'd end up with something like that. And hopefully that is a reflection in the line y equals x as well. That doesn't look too bad. Now for our last one, we've got a couple of things going on here. The 1/2 part, I'm sure you recognize. The numbers at the start change the height of the graph. So basically we're going to half each of the y values here. So this -2 is going to become -1. The y value here is 0. A half of 0 is still 0, so that doesn't change anything. Now this 3x part, that might be the one you've forgotten about. I think the best thing I can remind you about is the graph of sine x. When we looked at the graph of sine 3x, it actually did 3 loops within the same time period. So effectively what it does is it squashes the graph in horizontally. So 3, 0 is going to be basically 1/3 of this value. So it's going to be at 1, 0. Once again, remember when it's in parentheses, you tend to do the opposite of what it actually says. So normally when it says like x plus 1, you know to do negative 1. So where here it says times x by 3, you actually divide the x by 3. So it still follows that same kind of property, and something like that should work. Notice I am labeling my intercepts because that's what it asks you to do in the question, and if you don't do that, then you would certainly lose credit for that. And if you missed any of those ones, then there's all three together. Kind of a high-scoring question, 9 points, but actually it didn't actually take us that long to do, so it's definitely a question where you can actually gain back some time if you see this one on the AICE exam. Now, the specific objectives that are listed in the book you can see above. We covered numbers 1 and 4 in the previous lesson, so today we're going to focus more on 2 and 3. We are going to remind you about graphing functions, but also being able to interpret things algebraically is going to be important. We're not solving simple equations anymore today. We're moving on to something that's way more complicated, so we're looking at those AICE level modulus questions. So the absolute value makes things positive. Importantly, so does squaring something. So that new question, when we have two absolute values together and we have to solve them, what we're actually going to do is we're going to square both sides. We're going to remove the absolute value and then just square them. So for example, if I have a question like this, then I need to recognize absolute value equals absolute value, square both sides, and then actually we've just turned this now into either an algebra 2 or an algebra 1 question. You can clearly distribute. You should be, of course, trying to set this equal to 0 to solve, because that would make this easier to do. Divide both sides by 3. Move the negative 1 to the other side. And don't forget, when you do the square root, of course, there's actually two answers to this. It could be 1 or it could be negative 1. Now, you could also do this question by graphing, and that's why I left that in as one of the objectives for today. If you graphed each question independently, x minus 2 we have here, and 2x minus 1 we have here. If you look at where the intersections are, you can actually see that it's at 1 and also negative 1 as well, which is what we have here. Generally, we want to do it algebraically because it's more accurate, but you can use that as another check as well. If you have time on a question, you might want to check the other answer as well, just to make sure that you do end up with the same answer. All right, let's look at our second question. I put an inequality here this time just to show you that nothing really changes too much. We're certainly going to square both sides again so we can remove the absolute value. We're going to distribute. We're going to set it equal to 0. I brought my x terms to this side because I really wanted a positive x squared. Remember, if you have that negative x squared, when you divide by a negative number, then it's going to flip the inequality. So we've always got to be a little careful with things like that. I don't like factoring with a negative number either, so I normally tend to go for the positives on these questions. Go ahead and factor using any method you think is appropriate for this. And I went ahead and flipped this question back over because it's kind of like the wrong way around. Normally I want my x's on the left. So notice the inequality is pointing at the x's. So on this one here, it's also pointing at the x's. As I switch the sides, I switch the inequality over as well. Now from here, this is where people tend to do a lot of guessing, which is not a good idea. You should certainly be able to find the key values, as in 1 and positive 5/3. And you can draw the graph in to see that. And then remember what you're looking for in this. You're not seeing a nice U shape, of course, because it's obviously x squared. As it says less than 0, we're interested in when is it below the axis. So I'm looking between these two numbers. So in other words, those two numbers we just found, the 1 and 5/3, the answer would be between those two things. Now, if you want to see what that looks like graphically, I draw the two graphs. I'm interested when x minus 2, that's the one that's here because it's 2 on the x-axis, when this graph is greater than the other graph. So on this point here, you can see that this part of the graph is higher than this part of the graph. So it is certainly between those two numbers. It's not here, because if I look at this point here, you'll notice that the other function is higher. And the same on this side of the graph as well. You'll notice that this point is lower than this point, but I'm only interested in points that are greater than. Once again, you really want to do this algebraically if you can, because it's far more accurate, but you can use that as a check, and sometimes it will ask you to do. Be very careful on questions like this that you don't just square both sides immediately. This question is no solution. You can't have something that is positive equal to something that is negative, and it's kind of like that question we saw in a previous lesson. So just keep an eye out for that question. Now, if we add in an additional term, this question suddenly gets a lot more complicated. So notice I've got the absolute value on both sides. I don't really want to bring this term across to this side and then try squaring. It gets really complicated when you try to do FOIL with numbers and absolute values. So for questions like this, we're just going to create a table of values, and then we're going to fill in, and then we're just going to look at the property. When does the answer actually equal 3? Now, a couple of numbers I've highlighted here that are important. I am interested in this value here. So I know -2 would make this set of parentheses 0, and I noticed that 1 would also make this set of parentheses 0 as well. So these are going to be two key values for this question. Now, to fill in the table, you literally just plug in these numbers. So sometimes it's easier to start with a positive value, so I'm going to start with 3. So 3 add 2 is 5, 3 minus 1 is 2, and then 5 minus 2 should give me 3. And I should be able to, oops, what did I do here? Oh, sorry, plus. 5 plus 2 gives me 7. And then I should be able to do this for all the other numbers in the table. And I deliberately colored these in a different answer to show you that these are all the answers 3. So notice it's between these two numbers. So if we're writing the inequality to show that, I would say it's between -2 and 1. I do need the equal sign there because clearly it does equal -2, and clearly it does equal 1. Now you can't just list the answers though as -2, -1, 0, and 1, which is very tempting because that's what you see in the table, because I don't have every single value listed. If I looked at the value, say 1/2, which is not on this table, 1/2 plus 2 is 2.5. A half take away 1 is -1/2, but when you do the absolute value of it, it would become +1/2. And 2.5 plus a half would also give me 3 as well. So it's not just those numbers there, it's all the numbers between here, as you can see at the bottom here. So you just got to be a little more careful as you're doing that type of question. I would definitely recommend pausing the video, see if you can repeat that process that we just did, and then we'll take a look to see how you did. Alright, if you filled this in, what you should have noticed is these were the numbers that we had. Now this time I want when it equals 3. Notice it's all these numbers. So notice it's to the left of this key number. This is why I like to do this in a different color as well, to try and highlight that it's going to be something to do with this number here. So it's all the numbers to the left of -1, or what we're really saying is when is it less than or equal to, because obviously we can have -1 for this question. And that really covers all the examples. In the textbook, you should be looking at assignment exercise 2B. Do questions 3 and 4. There are 3 subparts to each of them. And then move on to miscellaneous 2. I put 7B here. There isn't actually a 7B, but there are 2 parts to this question. So the first part you don't need to do, and then focus on the second part. And that should do it for this video. As always, go ahead and practice now. That's the important part. If you need additional help, look below. There's my link to my YouTube page, and that'll do it for this video.